Hi there. I would like to start by thanking the organizers for the opportunity to give this talk and to thank you for taking the time to listen. So this work is from my previous postdoctoral position at the National Socio-Environmental Synthesis Center, which is part of the University of Maryland. So the motivating question for this talk is, how does dynamic territory formation and maintenance contribute to disease dynamics in a territorial solitary predator for an indirectly transmitted pathogen? Now, this question arose out of some other movement ecology work that I have been doing with a set of GPS data from collared puma in Southern California. And when we looked at that data set, we found that individuals were not only not contacting each other, but they were actively avoiding each other. And so that really got me thinking, what are ways that animals communicate asynchronously, and what are the consequences for disease transmission when those mechanisms are in place? Now, stigmergy is one way that this might take place. It's an indirect mechanism of coordination where agents leave traces or signals in the environment and other agents respond after the fact and modify their behavior. And so a really obvious example that most folks might know would be in social insects like ants or termites. But also this could happen for vertebrates, which engage in behaviors like scent marking or scraping. So to really get at this, I developed a mechanistic model of territorial formation for an asocial predator. And in this model, hosts can move in any direction across the landscape. As they're moving, they're leaving scent trails or scent cues. And as you can see in this time step, the blue individual has encountered the scent trail of the green individual and is now constrained in its direction of motion away from that scent cue. And then sort of the extra key trick here is that as hosts are leaving scent cues, if they're infected, they're also shedding pathogens in the environment. So if we put all that together, it looks something like this, where we have individuals navigating their landscape. As they encounter other host scent cues, it's potentially changing their direction and results in dynamic territory formation. We then use this framework to look at trade-offs between recovery rate, pathogen load, pathogen decay rate, scent load left in the environment, and how quickly the scent decayed once deposited in the environment. And then analyzing the resulting disease simulation outputs, we found that recovery rate was the most important predictor variable across outbreak success, maximum prevalence, and duration. Host density and pathogen decay rate were the next most important factors across these three metrics. And then when we compare territorial behavior as represented by the stigmergy simulation versus random dispersive movement, we found that territorial behavior does dampen the maximum prevalence that is reached in these simulated disease outbreaks. This is especially true for slower recovery rates. However, for slow pathogen decay rates and slow recovery rates, we saw that stigmergy-driven movement increased outbreak duration relative to random movement simulations. So in the parameter space of longer infectious periods and higher host densities, we saw some key trade-offs emerge. So for example, we saw highest maximum prevalence when we had a high initial pathogen load, a slower pathogen decay rate, a lower initial scent load, but a faster scent decay rate. And conversely, we saw longest outbreak duration for, again, high initial pathogen load, slower pathogen decay rate, but here's the switch for a higher initial scent load and a slower scent decay rate. So all this is to say that territory formation from indirect cues can offer protective effects, but at a cost. And I'd like to conclude by thanking my postdoc mentor and Sue Vanderwood, my co-author Megan Kraft on this work, as well as the other members of the Fellow Day team, Walter Boyce and colleagues from UC Davis, my various funding sources, and just a brief disclaimer that this work was not conducted while I was at USAID. And I will be happy to take your questions after we make it to the live Q&A. Thank you.